You and I are on a dim sum date, but our server forgot to give us 2 pairs of chopsticks. So that means we have 1 pair between us. We get our first plates of dim sum at the same time. Excitedly, I grab 1 chopstick and you grab the other. However, the date wasn't really going all too well. You think I'm pretty cringy, and I think that you smell. So there's no real way we can coordinate and actually share these chopsticks. Instead, we just stare at each other angrily with our dim sum plates right in front of us until the restaurant closes. That, my children, is a deadlock. For this video, we're gonna dive into how we can handle deadlocks in Golang using Goroutines and channels. First, let's define what Goroutines and channels actually are. Goroutines are basically lightweight threads. They are called this because they utilize a variable size stack that starts with 2 kilobytes of space, in comparison to the traditional thread that uses a fixed size block of memory, usually around 2 megabytes for its stack. Goroutines are scheduled using a special user space scheduler to avoid wasting resources in the kernel. Instead of a thread being equivalent to a thread in the kernel, which might be the traditional way, Goroutines are mapped M to N to an actual thread in the kernel. Goroutines also have a lifespan equivalent to the execution of the program that they are in. So if you kill the process of the program that they were started in, they all get killed as well. With this in mind, we need to make sure that we exit the process gracefully, unless if we don't particularly care. Channels are communication pipes that Goroutines can use. They behave similarly as a Unix pipe, where they can send data from one end and receive from the other. However, channels have the option to be buffered or not, where pipes might be usually buffered. Buffering in this context means that there's a specified length for the buffer capacity. Another big difference between pipes and channels is that pipes are created as unstructured streams of bytes, where channels can transfer specific types. Channels can even be type agnostic. Let's take a closer look at unbuffered channels in Golang. When a sender sends a value on an unbuffered channel, how does the sender know that the value actually made it? Well, in Golang, it simply just waits until it's received. Looking back at my original analogy, if I'm willing to be a kind soul and give you my chopstick, but you think it's gross just because I touched it and then refuse to receive it, then we're at another deadlock. Just like in this scenario for Golang, if there isn't a channel available to receive, then it will just hang indefinitely.
This needs to stop now.
All in a deadlock state. So we have 2 ways of going about this problem. We can either use a Goroutine or change the channel to a buffered channel instead of an unbuffered one. Unbuffered channels are very useful for synchronized communication between Goroutines. Even though this might sound like a headache that unbuffered Goroutines just block whenever a receiver or sender isn't ready, it actually is very helpful for multi-threaded, multi-Goroutined scenarios. It ensures that each side is 100% ready before sending any values. What you can do here when using an unbuffered channel to prevent a deadlock is to let the sender be represented by a Goroutine and then just receive on the main Goroutine. If your goal here is to keep your unbuffered channels, keep in mind the functionality of them as you design your multi-threaded program. The other way we can prevent a deadlock is to simply just change the unbuffered channel to a buffered one. Buffered channels only block if the sender is full or the receiver is empty. If our goal here is to just simply send 1 item or an X amount of items, we can just assign a capacity to our Golang channel and send and receive that 1 item or multiple items without any blocking. Please like and subscribe if this content is helpful. I hope you don't get deadlocked, whether it's in your Golang project or on a dim sum date. Bye!
Bye, bitch.